Welcome to the Valve Studio for July 3rd, 2017. I made some changes to the bench here, getting ready to do my design for AJ's record player amplifier. It's got those Pentodes, and we're going to modify that and use both those Pentodes in some configuration to build him an amplifier out of that old record player. Well, I had to make some changes to the bench to get ready for that. I'm going to go ahead and briefly go over those, and then we'll talk a little bit about what we're going to talk about in the next episode. So I'm going to switch over to my handheld camera here, and we'll go from there. All right, the first thing is I rearranged my power supply section. I have this thing here. This is going to be my plate supply. I think I got this at Habitat for Humanity Restore. It's an electrophoresis power supply. This is using them in the, I guess in the biology industry to grow cultures. And it's a 0 to 1,000 volts at up to 150 milliamps. This thing is great. It's very clean, and it does go up to 1,000 volts, and it does have a milliamp and a voltmeter there. Down below it, this is going to be my screen supply. This is a Fluke 415B high voltage power supply. I used to design electronics for the solar industry for high voltage solar monitoring, and I bought this supply to do some calibration. I particularly am a little bit scared of both of these. They're really dangerous. But what's nice about this one is it's somewhat calibrated, and the output voltage can actually be set. And these settings here are actually pretty accurate in terms of what it's doing. There is one problem with this thing. This panel meter is broken, but that's fine. This thing's kind of got a funky BNC connector over here. It's a high voltage BNC. You can't use regular BNC wires on it. They don't lock in. So I ended up having to print out these things. These are little adapters for my VIP prototyping system. Let me go ahead and show you what that thing is. All right, so over here, this is a little plate I bought at Home Depot in the tool section, and then there's a whole video on there on my channel about this thing. So I have a bunch of tube sockets that are wired in the terminal strips, and then they fit into these holes, and they're pretty secure. If I'm working on high voltage, I don't want the high voltage wires, coming loose. So that's what these are for. This is a banana jack for my plate supply, and then this is that BNC connector, and it runs over to this terminal strip, and then these will hook onto that plate and actually screw them in from the bottom to make them secure. So we won't have anything moving around, which is good. Let me see what else is on my bench here. So there's my scope. I got back out the RCA Senior Volt Ohmist vacuum tube voltmeter off the bench here, and also have a HP 204C oscillator. I have this one down here because it's easy to kind of adjust. It's just got regular knobs. It's an old school guy, and its distortion figures is okay for what we need to do. I think it's probably about 0.1% distortion. For guitar amplifiers, that's going to be fine, and we'll talk a little bit about We'll talk about how to have more accurate frequency generation here in a minute. I also have this old function generator here. It's okay as well, but it's digital interface. It's kind of a little difficult to use, but you can set the frequency and the output voltage pretty securely. Up here is a distortion analyzer. This is a HP 8903E. We'll talk a little bit about that in a minute. Up here along the top, let's go back down here a minute. Down below here, I now have my speaker switching set up. Remember, this is the one that can select between the speakers on the shelf up above. If it's in this position down here, it's down, and it actually hits the load resistors inside the unit. I can feed off of, I can have a 1/4-inch jack coming in, BNCs, and this is more of an output. So I can run this back up through my signal chain, which goes to the distortion analyzer, spectrum analyzer, scope, etc. And everything is all wired together, and for some reason this took a lot of time to do. All right, next addition to the lab here is a Sennheiser E609. This is a microphone that a lot of people use for miking speakers. And I have it connected up to this articulated arm. It's used for cameras. And then it's snapped onto my lab bench with a magnetic base that I got for an indicator, a mechanical indicator. All right, I got these things at a garage sale. These are old General Electric speakers. These are originally hooked onto some record player, probably around 1965. And I have one of these up on the shelf here. But I've replaced the driver in this with a Jensen C12R, which is I think it's a 50 watt 12-inch woofer. And then in the back here, the speaker that actually came with this is a 12-inch driver. And what's interesting about this is, that it's really low profile. And it probably doesn't have, much power, but that's fine. For this record player amplifier, this is going to be great, because this is going to go in where the record player mechanism used to be. So we don't have much depth, and this is going to work perfect for that. Okay, that microphone there, that Sennheiser microphone, runs down and it hooks into this thing here. This is a Shure microphone mixer. I got this off of eBay for parts. Primarily I wanted the microphone transformers. And I was going to use this in AJ's real guitar amplifier for a microphone input. So I needed this transformer, and this thing's it's actually got 5 transformers in it. And somebody had just cut off the power lead like it was just junk. So I figured, well, let's just try it. And I plugged it in, and this thing actually worked pretty well. One of these channels is blown, this channel 2 here. And the reason is, I think that somebody came in here at some point and replaced, this thing is just a single transistor preamp. And somebody replaced this transistor here, and I don't think they put in one that actually worked. I don't know, whatever. This channel doesn't work, but the other channels work fine. So I have my Sennheiser microphone plugged into this, and we will show you the output. We'll do a little distortion measurement with using this. I'm currently mic'd up to a JBL control monitor, which is used in control rooms. It's a 4311. This was a really good find. I found this one. Unfortunately, I only got one at Habitat for Humanity Restore for $5. This is an awesome speaker, high fidelity, and this is the other. This is that Jensen speaker up there. All right, one last addition here. I got a computer for the bench here. I didn't want to use my main desktop in case I end up blowing up something. I don't want to jeopardize my day job. So I bought an old Dell small form factor. This is a i5, and it's running Windows 7. And this thing here is a new addition. This is an Analog Discovery 2 from Digilent. There's been a lot of videos on this being used for analog work, as well as for guitar amplifier design. We're going to use this today to drive out of channel 1 on the waveform generator. It's going to go into channel 1 over here. And then this is an RCA that runs into my audio amplifier. Over here I have a Techniques old audio amplifier, and I got it running up. I got it patched into my speaker switch, and it's running up to that JBL. So what we're going to be able to do is turn on the oscillator on this, drive the JBL speaker on the shelf, and we're mic'd up on the microphone. We're going to go through this mixer here, and I have this the output of this run into my signal chain. So we're going to be able to look at distortion measurements. We're going to be able to look at the time domain data on the scope, and our old analog spectrum analyzer will look at the spectrum here, and then we'll also look at the same data down here, and we'll show you that we're actually getting pretty good performance out of what we have here on the bench today. So let me turn this on over here. This is liable to be pretty loud. Hopefully you'll be able to hear me. I had to kick up the volume in here to get out some decent voltage out of the microphone. But what I have over here is it's a thing called waveforms from Digilent, and this is the scope screen. This is the frequency generator section, and down here we've got the spectrum analyzer running. So I'm going to go ahead and stop the spectrum analyzer, and I'll start to scope up. And we're going to go ahead and turn the output of this on. And we're currently set at 1 kilohertz. And we can verify that by looking at my distortion measurement up here. And you can see that the distortion measurement is, the frequency is 1K, but the distortion measurement's kind of moving around. And this is eventually going to settle down to about 1%. And if we look at the spectrum over here, let's go ahead and run a spectrum here. So I'm on 1 kilohertz per division, and we are running at 1K. So this peak here is the fundamental, and this is the second harmonic, and this is about 50 dB down, which is equivalent to about 1%. Alright, so let's go down here, and we'll go ahead and run the spectrum analyzer down here, and we'll show that to you. Okay, now this, I didn't show you this, but my signal chain comes out of this preamp, goes into the distortion analyzer, spectrum analyzer, and the scope on my bench, and then it ends up getting kind of terminated in channel 2 right here. So this is the spectrum coming out of the, let's just turn this off. It's going to drive me crazy. Let's do a single shot here. Okay. Alright, so here's the spectrum down here. This is the 1K, and it's at minus 23 dBV. And then the second on this guy is down here at, it's way down here. At 2K, it's 70. So this difference here is about 50, which is what we saw. Here's the third. So we're pretty much down, almost 60 dB on this thing. And this is channel number 1. Okay, channel number 1 is this is the source. This is the source here. Well, that's not, let's turn on the actual thing that's coming out. Channel 2, let's do a run here. Alright, so channel 2 is the microphone at the preamp output. This peak here is at, we'll put a point here, and here's this is the primary, here's the second, and this is the third, okay? And the third is minus 46 dB, which is kind of what we're seeing on the spectrum analyzer above. So let's do one more thing here. So from a performance perspective, we're looking at just the signal itself, we should turn this up a little bit because we're down here in the noise. Let me see if I can figure out how to do that. No. Okay, I'm not quite familiar. Oh, crap. Right, so this, the second and the third on this thing are pretty much down in the noise, which is good. There is a peak out here, though. Where's this peak sitting? This peak is sitting at 7.5. This is actually some noise on my setup. I can show you that. I'm going to change the fundamental, and this peak won't actually move. So from this thing here, you can see that the output from the preamp, as well as that speaker, are really clean. No, we can't. I gotta look at this one. All right, so here's the output from the preamp. It's actually picking up some of my voice. Okay, let's just be quiet. Well, if we look at this just right here, here's our 100 hertz fundamental, and you know this stuff down here is 50 dB down. So our setup going from the analog discovery through the audio amplifier to the speaker to the microphone to the preamp back over to the analog discovery input, we're actually getting more than 50 dB attenuation on all the harmonics. So this setup over here is something that I got for, I think I got this for $300. And it comes with the analog discovery and this breakout board with B&Cs, and these jumpers on here allow you to do AC DC coupling as well as 50 ohm termination, and I also got two 10x scope probes for this for $300. The software is free, you can just download it. So it's got a really nice spectrum analyzer, a super clean waveform generator, and it has the two analog inputs. It also has a bunch of digital inputs down here. You can read more about it. I'll have a link in the show notes. I'm actually using this for a digital project. I'm using them as a logic analyzer as well, up to 100 megahertz. So this thing is a screaming piece of equipment for $300. So if we look at what we're replacing up here with it, I'm replacing a function generator, a scope, a spectrum analyzer, a distortion analyzer, and my logic analyzer, which cost me, I don't know, $5,000 or $6,000, and this thing I got for $300. All right, let's talk a little bit more about what we're going to do next. We're going to work on AJ's preamplifier, and I'll go ahead and talk a little bit about that on a preview for my next video, the one I've been working on, trying to figure out how to explain topic for about a month now. I needed this high-end equipment to actually do that. All right, let me see if I can get out my stuff here, my pile of junk. Okay. So I've been reading Marvin Benchco's Designing Guitar Preamplifiers, And there's a section in there about using a Pentode in a mixed Pentode triode mode, and he has a reference to this document here. And this is a calculation and design of resistance-coupled amplifiers using Pentode tubes. This is a Stanford professor, Terman, and this is Hewlett, the original Hewlett of HP, and a couple of students. And this is dated 1940. This is a AIEE, which is a predecessor to the IEEE. This is a document. I've read this document about 6 times, and I've not read anything that comes close to the detail on this on using Pentode tubes, and particularly how the impact of all the capacitors in a Pentode voltage amplifier are coupling into the frequency response. This one is really complicated, and this led me to this one here. This one is the choice of operating conditions for resistance-coupled Pentodes. This is from Langford Smith. Langford Smith wrote the Radio Designer's Handbook, and this one is dated. What is this one dated? This one's about 1940 as well. Anyway, on this one talks about intermodulation distortion, and specifically on how to pick your screen voltage to obtain different intermodulation distortion characteristics. This one here as well is full of graphs, which is an interesting topic. Intermodulation distortion for guitar amplifiers actually affects they call muddiness, which led me to this one here. This is from Communications 1946, and this one is entitled Dynamic Characteristics of Pentodes. And let me just turn this off over here. What am I talking about? All right, sorry about that. So this one is talks about how to choose the screen voltage such that you get different characteristics out. And if you want to design an audio amplifier with low distortion, you want to do something specific. And if you want a guitar amplifier with distortion characteristics, you do something else. These 3 articles are really get to the core of how to design voltage amplifiers with Pentodes. And let's switch back over to this camera. Okay, so I'm trying to get a setup going so that I can reproduce some of these graphs in some of these papers, so that you can kind of see what the impact of different screen voltages are. That's why I needed a screen power supply and a plate power supply. So I'm going to take some of AJ's tubes out of his record player, a 6AU6, and we're going to investigate different biasing techniques for different sound characteristics, particularly for guitar amplifiers. We're going to run our preamplifier output right into that audio amplifier and drive that JBL speaker, which has this whole setup I have here with the microphone, the amplifier, the speaker, the amplifier, the speaker, the microphone, the preamp have about 1% distortion, and that's not that audible here. But we're going to be able to make our preamplifier and show you, the impact of picking the screen voltage. All right, well, that's it for today. I'm going to wrap it up here. Thanks for watching. This is the Valve Studio.